Hey everyone, and welcome. Today we are diving into some absolutely incredible breakthroughs that are changing the game in how we build powerful AI models. We're going to talk about how a process that was once a total grind is becoming faster, smarter, and way more accessible than ever. So let's start with a question that, drives data scientists and developers absolutely crazy. You've got the data, you've got the algorithm, but getting it to perform at its best, it feels like this endless, frustrating cycle of trial and error. This right here, this struggle, is one of the biggest bottlenecks in all of machine learning. And this problem has a name, or at least we're going to call it the tuning treadmill. You know what I mean? It's that slow, manual, completely exhausting process of tweaking a model's settings, these things called hyperparameters, over and over and over again just to get a tiny bit more performance. It's a massive drain on time, money, you name it. The easiest way to think about this is like you're trying to find the perfect recipe for your AI. The hyperparameters are like the settings on a super high-tech oven. You've got temperature, cook time, fan speed, all this stuff. And finding that perfect combination is absolutely crucial. But with dozens of settings, trying every single one is, well, it's pretty much impossible. So, for years, how did we deal with this? Well, the machine learning world has pretty much relied on what you could call brute force methods. These are the old school and frankly super inefficient ways of trying to solve this tuning problem. On one hand, you have something called grid search grid. This is the ultimate brute force attack. It literally tests every single combination you can think of. Sure, it's thorough, but it is computationally massive. It can take days, even weeks to run. So then you have randomized search grid, which is faster because it just tries a random handful of combinations. But it's a totally blind search. It's just pure luck. And here's the critical weakness for both. They don't learn anything. Every single guess is a fresh start from zero. Okay, so this is where our first huge innovation comes into the picture. Instead of just guessing blindly, what if we could search intelligently? This is the whole idea behind a framework called Optuna. It's all about working smarter, not harder. And this quote right here, it just perfectly captures that shift in thinking. The goal isn't just to search, it's to learn from the search process itself so that every new guess you make is better than the last one. So how does Optuna actually work? The best analogy is to think of it like a master chef who's perfecting a brand new recipe. First, it tries a combination of ingredients. We call that a trial. Then, based on how that tastes, it updates its whole understanding of what works and what doesn't. And this is the crucial part. It uses that new knowledge to intelligently suggest the next combination to try. It's not just guessing anymore. It's learning, it's refining, and it is wildly more efficient. Okay, so Optuna makes this search for the perfect recipe smarter. But now, let's talk about an even more profound idea. What if the model itself was so smart it didn't even need you to search for a recipe in the first place? Seriously, let that sink in for a second. What if you could just take a model, hand it your data, and get state-of-the-art results instantly, with zero tuning? This isn't science fiction. It's the promise of a whole new class of models that are absolutely changing the game. They're called tabular foundation models, or TFMs. And honestly, the best way to think of them is as experts in a box. They have been pre-trained on this massive, diverse collection of data problems, so they've already learned the fundamental patterns of how data works. So when they see your specific data set, they just apply that huge library of pre-existing knowledge to give you a great prediction right away. So let's look at the evolution of one of the leaders in this space, tab-PFN. Version 1 was basically a proof of concept. Version 2 made it a really practical tool. But just look at the jump to version 2.5. It can handle datasets with 50,000 rows and 2,000 features. I mean, that is a 20-fold increase in the amount of data it can handle from the last version. This scale up here is just insane. And the performance? Okay, get ready for this because this is staggering. On small to medium datasets, the latest version has a 100% win rate against default XGBoost. And if you know machine learning, you know XGBoost has been a titan, a dominant force for years. And tab-PFN has a perfect record against it, right out of the box. This chart just illustrates the payoff perfectly. On the left, you've got your traditional models that need a ton of tuning. In the middle, you have a really complex system called AutoGluon, which actually takes 4 hours of tuning to get its result. And then, all the way on the right, tab-PFN 2.5 hits that same world-class performance instantly, in a single forward pass. So we've seen a smarter way to search, and we've seen a smarter model that doesn't even need a search. So now let's connect the dots, because this is where the story gets really beautiful. This is the big aha question, right? Even a revolutionary model like TabTFN 2.5 has its own internal settings, its architecture, its training parameters. So how in the world did its creators find the best ones? Trying every combination would have been completely impossible. And here it is, the punchline. They use the exact same principles of smarter searching that we just talked about. They use the previous model, TabPFN v2, as a fast, efficient guide to predict which settings would work best for the new, much bigger version. It's this brilliant kind of meta TabPFN tunes TabPFN strategy. So, what's the big takeaway here? Why does all this matter? Well, first, development gets so much faster. We're talking hours of tuning just vanishing. Second, this makes powerful AI way more accessible to people who aren't deep tuning experts. Third, it just sets a new standard for performance. And finally, and maybe most importantly, this is a fundamental paradigm shift. We're moving away from brute force labor and towards leveraging pre-trained built-in intelligence. And all of this brings us to one last, really provocative thought. We just saw a real-world example of an AI being used to intelligently design and build a more powerful version of itself. If this is where we are today, it really makes you wonder, what's next?